QR code and a link to get you to a little app called Slider. Once you're on that app, you'll find a question. We'll be using this throughout the presentation this morning. So if you get on, just stay there, and we'll have a chance to hear from you as well as speak to you. Our goal this morning is to cross boundaries. We are a cross-disciplinary team that believes very much in integration. So our theme this morning is how can we work better together? I'd like to introduce very briefly our panel, and I'm going to just point them out to you and ask each of them to say a few words about themselves. So I'll start here with Craig Stevenson, who is the president of the AUROS Group, a consulting building performance organization. Craig comes from 27 years in the construction industry himself, so he brings a very broad background to the work.
Thank you, Stephanie. If you guys can't hear me, just raise your arm and try to get closer to the mic. My name is Craig Stevenson. I'm with the AUROS Group. AUROS Group focuses on the intersection of building science and data science. So we do a lot of high performance construction projects defined by low energy consumption and indoor air quality typically, but we are able to also look at other parameters of building performance as well. What we do more than anything else is simulation. We do it every day, all the time. That's sort of our superpower. And what we've done over the last few years is we've been able to merge the dynamic data from our simulation into platforms that trend data. So when we see the trended data from meters and sensors, we can give it context with simulation. That's valuable when you get into monitor-based commissioning, interrogation-based commissioning, and testing analytics. So that's what we do. We're here today to talk to you guys about smart building technology and how do we get that data in a location that we can use it during operations for buildings.
Next to Craig is Donny Walker, who heads the intelligent building systems for Newcomb and Boyd.
All right, thank you. Yeah, Donny Walker, I'm a partner with Newcomb and Boyd, and I lead our technology group, which is all of the traditional technology, IT, AV, security, but also our intelligent buildings group that we started about 10 years ago, really focused on integrated building systems, and developed an approach of designing the entire building as a system of systems so that everything works together. And part of what I'll be talking about today is how the Division 25 format fits into that process and helps us to design a more holistic, cohesive building systems.
Thanks, Donny. And next to Donny is Trudy Van Kirk.
And I'm not sure if this is working or not. Is it? Okay. Trudy Van Kirk with D'Agostino Electronic Services. Thank you all for being here. I've had opportunity to, or I should say we have, work on projects with both Craig and Donny. We are a low voltage electrical contracting company, and I think all of you know what that is, but more specifically, we provide the foundations, the structured cabling, physical security systems, access control, surveillance lighting. We do multimedia solutions. I've worked with many of the architects in Pittsburgh on multimedia rooms in and around and training rooms. We do network services. We actually sell network equipment, sell and install and maintain network equipment, and we have a new lighting division which is concentrated mostly on POE lighting, although we will do other kinds. That's our newest division at this point. And we do have an AI group that specifically looks at customer problems and how we can solve mostly manufacturing type issues where you can put AI into it. So that's less of the things that you get involved in, but certainly our structured cabling, our multimedia, our security. I talk to some of you every day about it. Thank you.
Thank you. So you can see our team spans a great deal of skills and areas of expertise that we need in projects today. And we're going to talk about the way that we actually get from great intentions to great results. The other two on our team sustainable world, and we all want to do our part. We know the value of green building, we know the theory of it, and we actually know a lot of the obstacles. So as you've been contributing to your answers through the Slido app, they show up here automatically, magically, of course, so that we can start to see collectively our experience and our thoughts about these issues. Well, we've all experienced the difficulty of transforming an owner's good intentions into design targets and then into operational quality. It is a new world almost every day. We never know what materials are available. We don't know how quickly we can get things accomplished. And technology is changing the field in which we operate. So while things become increasingly critical in terms of the impact that our buildings have on the world and on the climate, it's also increasingly difficult to have a handle on those technologies. We know that we need better building performance, we need better predictability of our outcomes, we need to be able to control our owner's budget, and ultimately we need better client satisfaction, not only in the process, but in the operation of the building. So all of these are calling for more applicable knowledge, better client education, more teamwork, more flexibility, better design strategies, better questions for clients, a clearer idea of risks. It's challenging. All of those elements require more than any individual has. It's a team effort. So we believe that to do this right today requires really three things. A good team, a team that knows how to work well, and also has the right tools. So first we'll talk about a good team, and here's your question. Who are your strongest champions when you're designing for sustainability?
I should say there's no wrong answer.
And you can rank them. So if you feel the technology consultant is the strongest, put that first. So let's see who gets to the top. To see it moving as we go along. Is our ranking. Architects, go architects.
Okay, looks like that's where we've arrived. Architects are out there, taking charge, leading the pack. But we also know that all of these others are key as well. So it's quite a big team. Well, let's talk about the role of the architect changing. We know that putting together the right team is now more essential in our work than ever. As projects become more complex and new technologies emerge, we need new expertise. We find our own role is less clear and more demanding. If we can put together the team with the right expertise and a clear idea of what we're doing together, we have opportunities for more exciting and influential work. So as architects, we have to focus on the delivery of our documents, but we start very early in thinking about how we deliver the client's goals as we do that. We need a team from the very beginning that enables us to be the client's trusted advisor and strategist. So finding the right people is our first step, and often something that is rather daunting. We're going to ask the panel then to give us their perspective on this, and I'll start with Trudy. What role does design assist play in smart technology? What is the role of the contractor or vendor?
The role that we would play is that if you bring us in early in the project, we have the ability to add value, add confidence to your project. You know that you've got expertise on it. So there's the value of the design expertise. If we're in the design phase, we're gonna ask the right questions in order to get the right answers. I mean, there are lots of different answers to what's the best way to cable this building? What's the best way to put AV in this room? And we're going to talk with you, talk with your client, and then put together a design that works for them. As far as, how do you engage us? You will, call me and say, hey, we've got a project we would like you to assist us on, and we will, I'll get the right expertise within our organization, and we will come and support you however we can.
So we need the technology experts who know in depth all about the role and the process for building technologies into the process from the beginning. But we also need people who see the big picture. Donny, do you want to mention a little about
Sure.
that?
Yeah, I think one of the reasons that you bring in consultants into a project is for risk mitigation. It's for bringing someone that has an expertise in an area that you may not have internally, and it's for assigning responsibilities. So just kind of a quick question here. How many people routinely see the Division 25 integrated automation used on your projects? It's not a specification section that is historically commonly used. When CSI modified the division format and added, Division 27 for communications and 28 for security and safety, Division 25 was added in as a part of integrated automation to really help tie all of the building systems together. But even at that time, as all of the specification formats issued their standard specs, guide specs, and things like that, that specification section was listed, but it was left blank. No one filled it in. There was an understanding of the need, but no one had really developed it. And so what we have seen as we've really gone through and helped develop not only that specification, but there's an entire business and ecosystem around that integration. There's a lot of new terminology like operational technology, which is really that technology component that's all of your building systems, your building automation, your lighting control, your metering, your automated shades, all of these different things that have to work in concert together. How they all come together and fit into the building, how they're networked, all of those types of strategies, where they share data with each other, all of that is covered in the Division 25 model. And so one of the things that we see is that it's, once you kind of see that in place and in action, it becomes such a critical part of delivering a project successfully that has really strong performance metrics. Now you see that technology can't be somewhat of the afterthought that it was in the past. A lot of times in the past, you'll have architecture, MEP, civil structural doing the overall project, and then the technology is kind of like, well, that's something that comes in later. It's just, owner brings it in and it just kind of happens. Whereas, as you see the performance requirements that rely on that technology, you start realizing, no, really, my network, my cabling, all these things have to be designed in not only early, but delivered early to the point that your building systems are live to be able to really validate that the building works.
So we can see how easily it becomes unwieldy to assemble a team of experts. Craig, how do you bring together a team that is both capable in scope and also affordable?
So that, the answer to that question is we have to redefine the processes of how we go about this. Like Donny said, if you add technology as FF&E, at the end of the project, you're gonna pay a premium. And what we're saying is we have to think about this earlier. So you guys are all familiar with architectural programming. It's the first thing you do when you come on a project. You want to define the scope, find out how people interact with the building, how they flow through the building. What we do, what we bring to the table very early, right after the architectural program is finished, late conceptual, early SD, is we do an operational technology programming session. And that's critically important. If you're an existing building, we need a baseline systems. We need to understand our communications in the building. If it's a new building, much easier, but again, it's like the McLeany curve. The cost of money is cheapest right now. The longer I wait, the more expensive it gets. So we go through an OT, an operational technology, sorry, trying not to use acronyms, it's a habit. We go through an operational technology programming meeting. Do I need that technology? If so, what's the variability on that? For example, security. Do I need CCTV? Yes. Do I want it on every single door or just on the outside doors? So there's a variability there. And then how does that OT communicate with the other systems? That's what operational technology programming is. We do that, we use that result and document with our RFQs and RFPs to onboard our team, whether they're sub-consultants, whether they're the MEPs, whether it's a design assist contractor. That document is used because it defines scope. The second thing we do very early and in parallel with the operational technology program is we run through a discovery shred. I'm sure you guys are very familiar with discovery shreds. You guys write down those project requirements all the time. The differences between what we do and what you traditionally see in an OPR is we do metrics. There's a reason why we do metrics. So we define our air quality, our lighting, our sound by metrics. And we look across all the certified sustainable programs for our context and what is good and what is bad. When we get to there, it gives us the ability to start creating use cases, right? If we bring in a technology partner and we tell them we want smart building technology, what's the scope? Are they gonna put an outlet that's meter and sensor on every single outlet? No, we don't need that. Our OPR doesn't require that. We need to create a use case from our goals and targets set forth in our OPR to the technology we deploy in the field. That helps inform the operational technology. So what we're gonna talk about today here is we're gonna talk about process, right? There's no one answer that fits every single building. But if we have the right processes in place, we start making our decisions better, we make them earlier, and we can make sure that we meet our budget because we're doing that iteratively as we go through the project. So our goal isn't to design a high-performance building. Our goal isn't to construct a high-performance building. Our goal is to operate a high-performance building. And the only way that can be done based on what we see is merging building science and data science together so that we understand how to operate these buildings for 50 years.
Thank you. So saving your questions about teams till we have a discussion about it, we're gonna move to the second key element of good process, and that is about teamwork. So here's your question. Which of these processes do you currently include in building design? Budgeting lifecycle, data management, goal setting and performance metrics, technology and operations program. Okay. Well, we're definitely seeing the importance of commissioning, the importance of the final result. That's something that we all understand. Expertise on our team is the beginning step to getting there, but setting up a good process is not easy. We know that expert consultants like a well-defined problem. They want to put their time to good use, and they certainly don't want to do anything more than once. But we know that that also leads to silos. Designing siloed systems is what produces wasteful buildings. It's the process that still produces most buildings today, but not the highest performing ones. In fact, even a team of experts in a conventional linear design process cannot produce a really green building because it doesn't perform whole building design. It's the interaction among the building systems that makes possible the high performance without the high cost. So this requires new management skills. It's an iterative process. It involves many design cycles, many shared work sessions. It starts off with our first what if to generate alternatives and has
process. And I think that that reality of the data that all of the building systems produces going into that operational model has created that need for that additional element to the project. And so there's some information in your handout that you'll be able to take with you that has kind of two different views of the building systems that are involved in projects. And so one of them is kind of that network architecture diagram that shows how everything all fits together. But then the other one shows how that is divided up into the normal divisional formats and how they all intersect. And so, the architect is responsible for the entire building process, for managing all the consultants, for really, identifying those requirements and ensuring success. And so, these tools are ways to help make sure that all of those components are coming together to basically deliver that final result. And so we saw from the answer there that everyone is familiar with the requirement of commissioning, because you want to make sure at the end of the project that it's actually performing the way that everyone set out for it to. But then one that was a little bit lower, because it's not as commonly thought about, was the data management. Well, for commissioning to be able to do their job, they have to have access to the data. And so, a lot of times you'll see a commissioning agent say, well, I think everything's performing, but we're still having these issues with the controls. So maybe the controls contractor is trying to kind of finalize their piece, and that's holding up commissioning from being able to tell everyone that that is working in concert. So we've seen that operational technology really requires a deeper level of commissioning of do those systems work. And then once you know that the systems are working, it's much easier for the commissioning agent to say, now that I can really holistically test the building, now I can tell you the building works.
And Craig, you mentioned the importance of specific goals at the beginning of the project. How do we keep the team accountable to those goals throughout the process?
So what results from our early programming that we discuss is we develop a list of standards. And those standards are considered best practices for the project. So they can be open integration. If you guys understand the differences between open and proprietary technology, think of Niagara system for a building automation system versus a Johnson Controls Meta system. I like to pick on Johnson, so no fault of their own. But again, the idea is that we want to deploy our technology in our building, but we don't want them to control us and own us. When that relationship needs to be changed for whatever reason, we can jettison that technology and bring in another technology for all of it. So if you could do me a favor, Stephanie, flip to the slide with the graphic that we put up, a couple more. We can't get through.
Yeah,
They do on the,
yeah.
that's on the, it's not visual, that's only in here. But the idea is, we gave you guys a graphic to describe what smart building infrastructure is. Smart building infrastructure is made up of operational technologies. Building automation system, fire alarm, security systems, there's 25 of them. Those are OTs, right, operational technologies. Then there's a converged network, typically on these buildings is where the whole macro trend in the market is going to. A converged network combines the enterprise network, phone, Wi-Fi, data, with operational technology networks. Historically, we bring in a BAS, they run all their conduit and cabling to all the distributed technology, the VAVs, the meters and sensors, and it happens everywhere. Fire alarm, BAS, everyone's running separate networks. We have 50 networks in our buildings. We're moving that into a converged network because we're saving a lot of money on conduit and cabling. If you don't believe me, call D'Agostino and they'll tell you how to do it. So that's where the market is moving on a converged network. We have a data aggregation component that's open. So the center of the universe in these smart buildings isn't the BAS as much as the proprietary vendors would like you to believe it is. It's the data aggregation component, which could be a Niagara Jace, it could be a Destec piece of equipment, where we want to consolidate and bring the data into one place that changes the language to one protocol that we can then get into an independent data layer. That's the single pane of glass. That's where all of the disparate network data resides. From there, we can connect to anything. So when you think about the macro trend, you're probably hearing about digital twins. You're probably hearing about SkySpark and Code Labs. And all these technologies that are emerging, we call them advanced data analytic layers, and they're coming into the market and they want to basically take over and control a building like the BAS proprietary vendors have done for years and years and years. The smart owners are looking at this and saying, no, I did that for 20 years, I'm done doing that. I want to be able to pick my service providers when I want them, and I don't want to lose infrastructure, I don't want to lose data, I don't want to be controlled by a vendor. So the idea here is, if you look at that image that we put on, Donnie's image is much more detailed, saying the same thing. My image is much more streamlined, and it's just meant to convey process. There's a way that we can do that open integration architecture and do it at par, because we're saving so much money on the converged network, and we're picking open operational technologies as opposed to proprietary vendors. So there's a way that that can be done. We've done that on a few projects, and when we get to the Q&A, I think we can answer any questions in that space.
And Trudy, as a vendor, how do the contractors and vendors in this process help to maintain accountability to the architect's goals?
Well, we first establish a budgetary price for you all, so that, I mean, you need that, and then secondly, beyond that, we go after the best pricing. Once we have settled on a design and we're working with Donny's OPR and we're all communicating as a team, then we've settled on that design, we can go to the manufacturers and get best pricing. We can go do an ongoing cost validation with it. If we find, like right now, we're finding that you can't get a truck in Shanghai to deliver chips to take them to the port, and even if they could, they can't get out of the port because all the ships are backed up. We've had this situation with a fairly large bank installation where we had to change everything that they were going to use for control in their AV applications. And it did not affect the functionality, did not affect the pricing or anything, but again, it was an open system so that it is going to operate in the same way and give the same results. So I guess it's a proactive situation where as sitting down in a team, we're all working together, and there aren't any surprises for you, the architect, because we're providing you that confidence that you need.
So the team is working together to translate the owner's intentions into operating goals for the project that the team is committed to throughout. We're now going to move to the third idea, which is what tools do we need to make that team and the teamwork effective? So what tools we're thinking about is not just tools that we use during the design process, but thinking longer term about setting up systems that the owner will be able to use in operating the building more intelligently and more successfully. This is quite a close, exciting race here. All right. So, yeah, it's very interesting. We'll have to talk more about how the environmental quality is such a key issue today. I'm not surprised to see that it's on everyone's mind after the last 2 years. But certainly a lot of other aspects of this are emerging as important as well. And now we have the tools to be able to measure them. So we've always been concerned about comfort of people in our buildings, about quality of air, but we now know that we have better control over the performance, and our owners have a better way of monitoring that over time. Automation and digital tools have transformed architectural practice. Technology and innovation continue to redefine that process as well as the outcomes. From calculating heating loads to modeling moisture migration and acoustics to dynamic lighting controls, these tools enable us to make better design decisions and have confidence that our decisions will produce the outcomes we intend. The more powerful the tools, the more critical it is to know which ones to use and which ones our owners need to use. This is an increasingly difficult task, as Craig just mentioned, the software that's flooding the market all the time. We need the expertise to know what tools our owners can best use, how to use them and when. And we need a process that makes sense of the information that these tools provide. Most fundamentally then, as always comes around to us as architects, we need to know the right questions to ask. So when we talk about tools, Craig, which are the tools that contribute to predictable outcomes? And can you tell us about the OPR?
Yes. We mentioned two of the tools in my previous answers, and one is an owner's project requirement built on metrics. And then the other one is your operational technology programming document. Those tools are working documents. Think of them in the way in which you would think of a project schedule. We create the baseline, we update it. Every time we hit a complexity in the project, whether it's a schedule, price, budget, material availability, we go back to those documents and we use them as our guiding principles of how we make better decisions, so we don't have to jettison the entire package and we can still manage our standards. So those are the two most important tools. There are two other tools that I want to mention too. Number one is building simulation. The landscape of building simulation has changed. The technology exists today for us to operationalize that energy model. We do that every day. We do that all the time. So you can do that in IES, eQuest, Energy Plus. Those are dynamic simulation models. From those models, we can export all forms of energy. We can export temperature, humidity, and CO2. We can export them in zones. Anywhere my man here can set up a sensor or a meter, I can set up a simulation for it, and I can give it context in operations. So the idea that simulation is changing is no longer used for transactional purposes. Bring up a model, spend all that money, size my equipment, we're done with the model. We take that model and we keep reinforming it as we make our decisions in design till you get to the 100% docs. We go into commissioning, we do all of our field testing and our QA/QC. All of that information reinforms back to the model so that by the time we hit punch list, that model is a highly calibrated model. And then we burn that model in. And when I say burn it in, the building and the model have to align, because then it gives us our context moving forward. Now the model resides with the owner. They own it just like they would own a BIM. And they can use that model in the operations on the technology. They can use that model to make better decisions when they do renovations or have life cycles. The second tool I want to mention is the data layer. We cannot understate the importance of an independent data layer. Get your data in a building. If you're gonna have this conversation and you're gonna go down a Div 25 pathway for your client, your projects, you gotta get them to a point where they own their data. Now, that's a statement I'm making, and I need to make sure we understand what that means. Having it into a cloud that someone else owns, having it into a proprietary VAS, you don't own your data, you have access to your data, you get it. But if you lose that relationship for whatever reason, you lose the historical data, or they give it to you in CSVs, which is just unmanageable. You need an independent data layer that brings in all the disparate systems into one place, and that's where the analytics reside. That layer of analytics resides on top of the independent data layer, and our layer of simulation comes into the independent data layer too. So that's how that is managed and thought out. And again, we gave you guys a diagram to use in your planning processes for how to think about open technologies.
So we think a lot about data when we think about smart buildings, but data really is not the point. Data is just part of the tools for giving our owners the ability to manage intelligently, and that requires diagnostics. That requires the ability to read the data in an intelligent way, not just to find out what the energy is being consumed at the time, but how does that compare to the design target, to what was commissioned, to what is expected. So in all of these ways, we have to be smarter about the role of data in diagnostics. And Donny, how about telling us a little bit about how engineering works today to give us that ability?
Sure. So speaking of tools, one of the tools that we're responsible for is a well-articulated responsibility matrix that begins in design, and then that flows through the construction process. And so, to avoid duplicating cost and to avoid different members of the delivery team adding cost because of either the unknown or the perceived complexity, you have to clearly articulate those responsibilities and make sure that you're not asking two people to convergence, it really eliminates that duplication, and that's how we're able to deliver smarter, high-performance buildings at cost parity, because we're reducing the amount of complexity by really properly engineering that, and then making sure everybody understands those roles and responsibilities. And then on the fault detection side, this is the ability to have an analytics engine that is evaluating the data would be somewhat similar to if you have a building that's high performance and you're maybe not seeing the performance that you would expect, you're typically going to call someone in, maybe a commissioning agent, maybe one of the engineers that work on the project, and have them evaluate the results, evaluate the data, and they're going to spend time and resources in doing that. The analytics engines that are available today are able to do that 24/7. And so, rather than having someone that's going to sit in front of a computer and look at this data and use their skill set to help define what's going on, you've got that happening at all times, 24/7. You've got the ability to run performance tests and commissioning results at the push of a button. And so, you can really start to see how that data layer becomes important when you think about the tools that are on the back end that are using that data that can now tell us exactly what's going on with the building, exactly when it stopped performing the way that we were expecting. And so those tools allow us to do what we're doing today.
So we have these capabilities, we have these tools. Trudy, you're closest to these technologies. How do you help owners pick the right technologies?
I like to say that we provide the nuts and the bolts of what they do to make it all work. The criteria that we have is that it has to be an open system. It has to be the ability to be integrated into their performance models that Craig and Donny put together. And in doing that, so we have to select the right operational technologies. We have to select the things that, as I said, are non-proprietary, that will feed us the information. Standardize on those so that we always know that we can make modifications as needed. And if you look at the access controls that tie the doors and the surveillance systems and everything together, that's got to feed information in the proper way to the tools that are used for the building analytics. I think, as any of us who have gone to school, a teacher will tell you that they're going to tell you what you're going to learn, they're going to teach you, and then they're going to test you on it and tell you again what you have learned. I think the process we go through is very similar. You're going to see what you're going to build. You're working together as a team, you're going to see what it is you're building, you're going to build it, you're going to measure the performance, and then you're going to make modifications whenever and however they are needed in order to establish this building that everybody is excited about.
So it's a very dynamic process.
Very dynamic. It's a living building,
Right.
living process.
So, here we have a quick overview.
So this is a document I mentioned in my response. This identifies smart building infrastructure. It doesn't get into standardizations yet. That's done through the OT programming documents that we create, but this gives you an idea of how data flows through the system and why the analytical layer must sit on top of the independent data layer. If it doesn't sit on the independent data layer and it becomes the independent data layer, then you have one advanced analytic platform, and when you pick that, you're going to be married to it for a while. Our clients are demanding upon us flexibility, future-proofing them for the next analytic, because let's face it, what we're seeing today is completely different than what we're going to see even a year from now in terms of analytics. We want to be available for that discussion, and you do that by having an independent data layer with the right data.
So by democracy, we mean independence.
Yes.
Yes. Okay. And here's something that you should look at in front of you.
Well, there's a pile on that recycling bin with all this stuff. So whenever you can pick it up on your.
And this is a diagram that shows really how the converged network serves as the backbone for all of the building systems. And so, for this specific illustration, we've got parking management systems, lighting controls for both the base building and the tenant spaces. There's your life safety, access control, AV room management, and so there's all of these systems. A lot of them have applications where they communicate with the cloud, so there has to be a clear way to get the data also the analytics themselves and the building operating environment. And so this is just kind of the illustration that shows the thought process that has to go into that operational technology network to bring all of that together.
So if it wasn't daunting enough when you came into this session, I'm sure you're feeling much more daunted at this, looking at all of this. So it's time for a review of questions. And you can submit them if you'd like on the little app, or you can do it the old-fashioned way and raise your hand.
So Trudy gave an interesting example of a problem in the process that you had that you responded to. For all three of you, can you share an experience where you had a hiccup or a road bump along the way, a speed bump along the way, and how you overcame that challenge?
Yes, and I'm probably going to send her mine on to AV. I mean, structured cabling would be the best place to put it, but I'll send her it on to AV. And there's two incidents that come to mind. One was the incident that we just had as far as the control systems. I mean, because we knew they had to be open, they had to be integrated into the entire system, because you're controlling a conference room or a training room like this. You know, you have to be controlling the lighting, you have to be doing, so that was, we were able to substitute product as soon as we knew that we were not going to have it and that they were going to be moving in next month. So that was one. The other one that comes to mind was before we operated as a whole team. And I went into a facility that we were doing, a very large training facility. We had dropped microphones coming, and they were going in this direction. And when I got there, it appeared that, and we'd never spoken about this, but the architects and the owners had changed the lighting. And now the lighting was going in this direction. So they were all going to run into each other. And that, fortunately, I happened to look at the plans and just said, whoa, we need to make some changes on this quickly. So, it involved the process of my going to the architect, here's the situation, here's what we offer as an alternative, and then my going to the customer and saying, here's the alternative, and making sure that it, that cost-wise, it all still worked.
So I'm gonna come at this from a slightly different angle. I'm gonna come at it from a process perspective. When we have been brought in historically on construction projects, the architects are working through schematic development, getting their massing orientation, their envelope all situated. The MEPs typically don't come in until DD, typically, just bear with me, right? So they come in much later in the process. The challenge here is it's a fundamental shift. It's a shift in how we do it. When we do building science, and we haven't had that conversation with you today, but it's related to this data science conversation, is, we have 23 passive house projects on our books right now, and we do a lot of high performance buildings. We're making our decisions on envelope optimization and performance at early SD. You have to, right? So now all of a sudden it's changing and it's affecting your layout in a building. We need these guys to start coming in and start talking about MEP narratives in early SD. We're making our decisions. The process is massing the orientation at the end of conceptual, envelope optimization early SD, and then we're getting into our mechanical narratives in early SD. That's a paradigm shift, and not a lot of firms are really understanding the impact of that. They hear early, like, yeah, we're gonna talk about it early. No, we're doing design, because if we don't do it then, we end up going to do rework when we hit the end of DD. The same thing applies to smart building technology. Having that OT program done in conceptual or early SD to understand legacy, how are we gonna manage an existing building? Where have these guys already trained all their facility managers on? What systems do these guys like? What do they use? Does their IT folks even understand what a converged network looks like? And the answer to that most times, 9 times out of 10 is no, they don't, and they're afraid of them because of cybersecurity. So we have to get that process started very, very early, which rolls directly into the MEP narratives. So from our perspective, the challenges we find on these projects is the teams have to fundamentally change the way in which they design these buildings. It's holistic and it's early, and we can't stress that enough.
There's a question on the side of, and I'm guessing maybe for Donny, are there established industry protocols that allow multiple systems to communicate, and how is this managed?
Yeah, absolutely. So there are a whole host of open protocols. You hear things like BACnet and Modbus that are more of the those traditional serial level protocols. But what we're seeing in today's systems and in new componentry is much more things going directly to the network. So you heard Trudy talk about the IP lighting, the actual controls are going to the network layer, and so really that IP is becoming the international standard for opening things up and allowing them to communicate. Now, anytime we get to a point where we talk about more things on the network, we also have to bring up the cybersecurity aspect. And so as we put more things on the network, we want to make sure that we're securing them in a way that they're doing exactly what they're intended to do and not introducing new risk. And so that's where things like modern APIs, give us that ability to harden and lock down the device to do exactly what it needs to do and not become an additional level of risk. So, but that IP layer is really what is becoming that standard for knowing that you've got a way to communicate, to talk to, and it's an international standard that is non-proprietary.
Another question for Craig. How do you obtain alternate cost information for various component upgrades for your machine-based optimization model, and what program are you using?
So when we model, we prefer IESVE because it's literally just 10 years in front of everybody else, and there's a lot of capabilities built into that. That's where we prefer to model, but we can model in eQuest or Energy Plus, and we can model in the passive class models of multi-passive and PHPP, so we're proficient in all that. Dina, remind me of the first part of that question.
How do you obtain alternate information for various component upgrades for your machine-based optimization model?
Yeah, so there's a reason why I'm involved in the independent data layer conversation, because when we were becoming experts in simulation, we saw the value proposition for using simulation in operations. We tried to bring that in through alternative measures. We tried to bring it in through data layers that are not independent. We tried to bring it in through the VAS. We tried to bring it in directly to other operational technologies. That's not fun, that's not quick. Donny mentions an API, I've written lots of APIs to connect data to those systems. It's not fun. And when you start getting into understanding why I created the sheet that I created out of necessity, survival, I had to do it. Getting to an independent data layer and getting the ability then to interject our data in there seamlessly and then be able to introduce that to the advanced data analytic layers made sense. It's quick, it's fast. We move very quickly through that. So as you get into this, it becomes really logical and apparent why we made the decisions we made to get to there. It's cost effective, it's fast, it's powerful, and it's way better than going into a proprietary lane. That's just frustrating. We have a question in the back.
What's your strategy for simplifying all this? Because I think sometimes clients say that they want this high performance building and they want all of this information up front, but then maybe their facilities folks change or the owner isn't as sophisticated as maybe they thought in the end. So how do you maintain this kind of process in a passive, simple way?
Yeah, I can take that. So really simplifying the process and the overall design requires us to start with the use cases of what are we trying to accomplish. And then it requires us to design the most simplistic way of achieving that. And so when Craig talks about that independent data layer, what is the data that we actually need access to make sure that the building is properly performing? And then design the building such that you are only asking the building for that level of components, that level of data. And so it's not just adding technology to a project. And I think lighting controls is one way. A lot of times people will say, I just want my lighting controls to be simple. And what they mean is they don't want a button panel with 50 buttons and you walk into a room, you don't know how to even turn the lights on. What they don't mean is that they just want a dumb switch, because that doesn't meet the performance requirements, it doesn't meet the energy code, it doesn't meet the basic levels of being able to properly control LEDs, to shave off dimming, energy harvesting, all these other things. So, what people hear when they say I want simple is I just want that dumb switch. What they really mean is I want the equivalent of that. I just want to be able to walk in the room and either the lights come on if that's how it's designed, or there's a simple button that I press and they or, is it something that's programmed on a schedule and they come on when they're supposed to? There's all of these different things to think about, but simple means simple to operate. It's complex on the back end to make it simple. So people want simplicity, but not necessarily do they want nothing.
Sorry, I was just gonna add one point to that in terms of the passive side of this. So we just finished a project together. It's a 171 multifamily unit, and it has another building next to it that's a commercial use. So it's, mid-sized type project. That project is full passive house, and the systems in that are really simple. So that's another avenue. If you go for high performance and use them a little for strategy, your loads go way down, and because those loads go way down, the systems that are required to put in place to manage those loads become much, much more simple. So it's, when I always think of a complex building, I think of a project like PNC Tower that is well known for its active wall and its systems and how it heats and cools. If you're in a passive house, it doesn't do that. We don't need a lot of heating, we need cooling, but the temperature variability in a passive house, if you turn the power off in a mid-sized building in a passive house, and 2 weeks later, it may change 2 degrees, that's it. There's not a lot of variability in there, so the systems also become much easier to use as well.
Okay, in building data, from Joe, okay? In building data, if building data for all building types, how is this scaled and implemented for smaller buildings residential? How can multiple buildings be linked together?
I guess I could take that. So we don't do single-family residential unless it's a group of buildings. And I happen to be working on a project with Stefani for an eco-village, and that's one of the problems we're trying to solve. So you would use similar but different systems. The operational technology in a single-family home are gonna be much, much simpler, right? So you're talking about a primary source utility meter, probably one for your electric, one for your water. There's not gonna be any gas in our building. And then an indoor air quality sensor, typically a Recid Air certified type sensor. So you're dealing with a much smaller group of operational technologies. The concept is still the same. Bring it to a data aggregation source instead of using a NAG or JACE, which may be $7,000 or $8,000. You can use a Honeywell Cypher system, and that's just a matter of like $1,000. It's much smaller. It's built for that size and scope. And then you bring it onto an independent data layer for that. The analytics on them probably are going to be real simple, but we've done that for single family. It's affordable. It's definitely something that can scale. In the independent data layer, if you have the right layer and you're using it the right way, that independent data layer can absolutely scale. In the system we have, it can carry, 8 million points in a system like that per server, per one server, and then we can do multiple servers for it as well. But the hierarchy that's built in there, when you look at it, it's time series data is what we're managing, right? So if you think about temperature every 1 minute or whatever scale we set it up to, it's just trending time series data. That's the same concept for every operational technology you're gonna deal with in a building, and how we set up those hierarchies in the data layer is really kind of logical and quick, so it can certainly scale.
At the portfolio level, you're really looking for what data matters at the portfolio level. So at each individual building, you may have all of the data that we're talking about for operating that building, but then, let's say you're responsible for a portfolio. Are you responsible for the maintenance? Are you responsible for the energy? Are you responsible for certain energy benchmarking efforts and those types of things? Those data points roll up to the portfolio level. And so you're able to take a very tried and true process for each building and then say, okay, I don't want to collect all of that, because we've got some large global companies that we're working with that manage things in 4 global regions. Those portfolio level metrics roll up to those global regions only for the data points that they care about outside of that facility. Everything in the facility is up for the FM team that manages that building.
From a user perspective, having worked with the AUROS group at East Liberty Presbyterian Church, we have a dashboard that is unlike what you would get from typical vendors. In this one, AUROS really designed a simple to read dashboard where it shows the energy that is used against the line
we think about all these things and how do you develop it and how do you design it, how do you put it together, and in the end result, it has to be human-centric. It has to be easy to use. It has to be meaningful to us.
I can't get through a session like this without talking about the people counting sensor technology that is on the market today. So, you know, one of the things that you think of when you look at a building energy model and that building performance is you have to make assumptions on how that building is going to be used. And the amount of people, you can imagine, like during COVID, many people found out about how their buildings operated while they were, you know, scarcely populated, and are still seeing that today. A really good building that has the you know, reactive systems and can react to its occupancy level is going to see variability in its energy usage. A lot of buildings throughout COVID saw no variability because their buildings are just, you know, kind of set it and forget it, and they do what they do. In fact, some of the energy went up because of the reheating that's involved in getting it to a comfortable level when you don't have the, you know, the people and energy load kind of, you know, providing that heat level. And so that sensor technology now gives us the ability, not just from an occupancy standpoint, to say, yes, we know this space is occupied, but it can tell you how many people are in this space. So imagine the HVAC and ventilation that can be saved when this room is being used by 3 people rather than the true amount of people that are in this space. And so that's just one of the technology components that gives us insight into how the building is actually being used, that Craig can use on that, you know, comparing the real data to the model data of saying, okay, this is what was assumed in the model, this is what's actually happening in the building.
Absolutely. Density analytics is a godsend for us, so we concur. But think about what he just said. Density analytics came out and it's only been innovated in the last couple years. In a system like we're talking about here in the openness, that plugs in like an app would plug in, right? Put density analytics up there, put them on the network, VLAN it off, get it into the JACE, it goes into the independent day layer. It's that easy. There's no other infrastructure. You're literally just paying for the cost of the density analytics system. This is what we're seeing in other OTs, other operational technologies that are emerging out of this market and taking advantage of this plug and play concept in buildings if you're set up the right way. Otherwise, it becomes a separate independent network that has to manage itself. We put them in, they have to get the data to their cloud, they have to visualize it on their HMI human machine interface or their dashboard, and we don't have any of that. We don't have the benefit of any of that data. We don't get it, and they own us. And then when we get rid of them, we literally we lose everything. We lose infrastructure. But if you have the basic infrastructure, you are available for all these systems as they come up. Again, that's why we call it sort of future-proofing.
You can also, you have these external links on your app, and I can even put up there, you can see what an OPR looks like. If you're not familiar with it. And everything we already showed here is, you can have access to any phones.
I think she's got enough.
While she's doing that, just a question about sensor technologies. How are they making it easier or more complicated these days? What's going on?
Yeah, I'll touch base on Reset Air and then I'd like you to hit the others. So we do a lot of Reset Air work. If you're not familiar with Reset Air, it is a world-class air quality standardization. It's a certification program, but it's not intended to be an independent one by itself. It's got crosswalks and it's embedded to all the normal sustainable certification programs you would use. What we learned by doing the Reset Air projects is there are a lot of indoor air quality sensors that get deployed into buildings and they have no way of ever recalibrating them. They turn into a brick after a year. And if you're starting to use that sensor to do things like CO2 on demand, activate our ventilation systems when the CO2 gets too high, if that sensor isn't calibrated, then it's really gonna wreak havoc on how that system operates. And that really just kind of drew us into a whole conversation, like what other sensors are we not calibrating? How are we thinking about this? So the meter and sensor market, Stephanie, is exploding in the built environment, and we're seeing it come from all directions. What we do in our programming is we start to identify which quality of level do we want for our meters and sensors, and then how do we recalibrate them? We're not saying we have to go out and buy Class A $5,000 indoor air quality sensors, but we don't want to buy the $20 sensors either and then rely upon them if we're going to do command and control or some level of control in our buildings. We want to make sure we have the right sensor that fits the right project. So that's how we see it from an IEQ perspective, but I'm sure you have.
Yeah, so, some lower cost sensors can be valuable with a lot of information that's being provided to help you from the analytics determination, understand how the building is performing. So when we're looking at sensors, we're looking for, what are those critical sensors that are controlling, a large amount of energy or a large portion of the building. So we want to make sure that we're getting those top quality sensors in those locations, and then, then a lot of that other information can be more crowdsourced from cheaper sensors. So there's things like vibration sensors that are going into more projects, light level sensors. There's the acoustical sensors giving you noise levels, and so
Those are still very expensive,
Yeah.
unfortunately. The DBAs are expensive, but everything else is coming down.
But so from a digital twin perspective, you can imagine that anything that you're looking to be able to manage to, anything that you're looking to be able to quantify, there needs to be some type of sensor that can give you that input.
Well, we have the example of the owner's project requirements here. Craig, you want to walk us through this?
Yeah, this is our take on an OPR. It's one page. It's 11 by 17, but it's still one page. And if you look down on the left side of this document, we group all of the building performance opportunities within the built environment, and then we break them down. So to the extent we can, we'd like to get to a metric because it builds our use cases for how we deploy our smart building infrastructure. And this is evolving. I mean, we improve this document literally on every single project. We put this out there, it's accessible and downloadable to you on the link. Feel free to use it, make your own. If you improve it, share back, spread the love. But this is how we see it, and this is why we use this as a metric-based OPR more than anything.
I can say as an engineering firm receiving this, if I have this document, I can put a proposal together for this project in a matter of an hour. Whereas a lot of times you reach out to a consultant and say, hey, we've got this project, and you start explaining it, and then you get a couple of days worth of questions. Well, are you considering this? Are you going to do this? And so they're trying to kind of pull that information out of you to get to that level of what level of sophistication are we going to have to design this building to. This one sheet says it all, so it's very useful.
We also have, if you go back to the top, Stephanie, for me. So we have built in a column for responsibilities, and we assign them to the project team so that we can talk about them. We talk about this literally at every progress meeting that we're attending and we come to. It's like, where are you at on this? Do you have any questions? Do you need any help? How's that pulling into all the technology? So again, feel free to use it, improve it as you guys see fit.
Any questions about this?
From a cabling perspective, this helps us as well, because whether, would a deep fiber environment work here? Because we can eliminate some of the IDFs on the floors. Would an UTG cabling system work well? So it does speak to all of that along with the actual design of the building.
Other questions?
I had a question about how this technology, all this equipment ages and how sustainable it is to make it. Do you have to replace it in whole or in time? Are you able to upgrade it over the years? And then I guess what your thoughts are about how the trades and the building owners and facility managers are prepared to handle all this and actually benefit from it.
Sure. Yeah. So on the technology standpoint, one of the reasons that we also advocate for the independent data layer is we look at the equipment itself as something that is producing that data, rather than saying I'm buying this system from this vendor, because that over time and technology even faster than other areas, you're going to replace that. It's going to fail. It's going to become outdated. And so if you're kind of tying into this more proprietary format, and then you go to that vendor and they say, oh, okay, great, you're on that release of this. Okay, you're at a point now where you're at a life cycle change. I need to take everything out and give you my new whatever it is. service. And so, you know, we look for any way that we can to keep owners out of that and say, you know, great, if we're gonna use some IoT sensors, maybe we know that that has a 2-year life cycle. Or with the indoor air quality sensors, maybe we know that there's a replaceable module, so let's build that into the operational process to say, replace that module, it's cheaper than calibrating the device, and now you've got good data again. And so, you know, we really look for that life cycle of any of the componentry, but know that there's a clear way to get that replaced and then get that feeding the data back into the model. From the use side of it, that is one of the reasons that we are very clearly looking at use cases. It's great to compile a bunch of data, but it's somewhat useless if you're not going to use it. And so that's where we get into, in our consulting, a lot of the operational discussions of how is this building being operated? Is it an in-house FM team, or do you outsource that? If you outsource it, what do those contracts look like? Are they incentivized to use that technology and to have your building perform better? Or are they, you know, basically only compensated, you know, as long as no one complains about the temperature, you know, those kind of things. And so, we really look to make sure that the operational model matches the level of complexity of what the building is being designed to.
I totally agree, and I'm gonna let Donny handle that from the Jace to the left, OTs, converged network, data aggregation. From that point to the right, data layer, advanced data analytic layers, if you wanted to toss that up. The independent data layer is software, right? So it's going to be upgraded periodically as it comes up, but for the most part, that's gonna be a long life kind of a piece of software for the independent data layer. The advanced data analytic layer, that's where I'm seeing the question that you're asking right now. And from our perspective, we want to be available for everything, right? Right now, SkySpark does fault detection and diagnostic, and they do it really, really well. We have that connected to our independent data layer, and that's running those advanced data analytics. But this whole industry is emerging. I mean, we've been to the Niagara Summit, we've been to RealCom, IBCon's conference, we've been to PyWorld, and all these conferences are filled with these students coming out of schools and writing analytics. They're all writing the next analytic, right? We want to be available for SkySpark version 2.0, right? Cut them, literally the single pipe that feeds them, and give it to the other one. Or you can use multiples. We may be in a project that has more of a concierge service for their data layer as opposed to more facility management, like a CMMS, which is a maintenance program, or a fault detection diagnostic, which is more facility management. Like Donny said, this might be feeding a different avenue. It might be doing billing for energy. All that sits on the data layer. How we make those decisions on the flexibility to manage the next version of that is really kind of what we've been focusing on. We want to be available for all the latest and greatest.
So if we are, then how do we know how reliable it is?
The advanced data analytic layer,
Yeah, all these analytics, how do we know the reliability of this?
well, reliability starts first and foremost with the fidelity of the data. And if we have good data and we understand that the data has quality to it, a good independent data layer will do that on the fly.
Is there checking?
Oh yeah, all the time. So yeah, we have that set up. So most of the independent data layers are doing that and checking, making sure we're getting data and making sure the data is accurate and is within the expected ranges. So those processes are pretty much automated at this point. Now they'll require people to oversee them, but you can set up notifications for that and get to that pretty quick. The advanced data analytic layer really depends on which one you choose and what you're doing with the data. And that's going to require a closer interaction with the end user, whether it's a facility management or someone in a C-suite looking for data. But that's kind of how we see it.
And that's why the operational technology commissioning and the building commissioning have to go hand in hand, because you have to ask, do I trust the data that my systems are producing? And if so, is the outcome what it is predicted to be? So there always has to be that physical check test. The technology cannot replace the commissioning agent actually coming to your building and validating that these things are physically happening. So you want to be able to do those two together, and now you can say, okay, I have physically verified that the data is true. Now I can trust the data, and so now you've got that ongoing commissioning happening. But if some people think that technology can replace screen going, oh, my building's operating great, look how everything's in the green zone, but it may not be reality.
Yeah, I get back to the very early question about how do you make this simple? How do you work with a client, say, who can't tell you what their operational technologies are? What do you do for the client? And I would have to say, I've never had a client who walks in saying, this is how I intend to operate my building. Where do you have that discussion, and who's involved in that discussion?
You want me to take it first? So,
Team.
we find this conversation happens a lot more in our high-performance buildings than it does in our code-based buildings. If the client is going to require you guys to design and ultimately participate in the construction of a high-performance building, they want to make sure they got their money back. This is what brought us to the entire conversation. You know, we grew up with LEED, right? So we built dozens of LEED projects, and I've watched greenwashing, and I watched owners say to us, I've been, you know, told if I do this, I get that, and I'm not getting that, and it's been years, and I'm frustrated. Climate change is on top of us. COVID is on top of us. We want to bring people back to work. How do we build healthier buildings? And for us, we looked at them and said, listen, there's a way to do it. There's a strategy out there. It's an envelope-first strategy that's the most robust strategy for getting at high-performance buildings, pre-renewables. It can be done. It's being done. We see case studies on it. And then the owner goes, okay, I'm interested. I see that it's working, but I want to make sure that I got my payback. That's the feedback loop. That's why we got into this conversation. That's why we started figuring out 6 years ago, how do I export my dynamic simulation, put it on top of my trended data, and tell my building owner he won or she won, right? They're asking us the questions. It's not that they're unwilling to invest, it's that they don't trust us anymore. And what we have to do is gain that trust back. Well, what's the quickest way to gain the trust back? Turn the lights on. They know instantly. You either got what you paid for or you didn't. And we want to do this at punch list. I don't want to waste my warranty year and then everybody on the project basically rolls off. I want to be able to hold people accountable to what they promise us to do. So on our building science side of the conversation, we set up similar processes on how we go through design support using technology to verify that the buildings can do what we promised. And then we set up commissioning, which is different than traditional commissioning. We're doing envelope commissioning, we're doing DIP 25 commissioning. Our commissioning has changed. And we're doing all that work because we want to make sure that we build the building we promised that we're going to build. Now, the biggest piece of the puzzle, how do I operate this building for the next 50 years? The only way we know how to do it is set up buildings this way. So it becomes a requirement on building owners that are investing in high performance buildings, whether they're doing through legislation, New York City, Boston, and others, or they're doing it because of corporate sustainability reporting that they have to get to it, or they're doing it because it's the right thing. And then the question becomes, how do I get here? I don't see as much of this happening in the code base, race to the bottom, if you will, type of buildings that are going on, because they just don't care. It was never part of their OPR. They never really made it part of their goals and targets. And then why am I going to set up a smart building to give me a feedback loop on something that's unimportant or not prioritized for our client? So we don't see it a lot happening in those types of buildings.
Yeah, I was going to say that I think operational training is such a big part of that. When you ask the normal design team member doing high performance what the EUI of their building is, they know that number. It's something that they thought about, that they're proud of. You know, we targeted 22 in this building, you know, and those kind of things. You ask the person operating the building what the EUI of the building is. What's an EUI? I don't know what you're talking about. And so when you start making that data available and having them be able to monitor that ongoing and make them a part of that equation, that you operating this building sustainably is where the rubber meets the road. Now they can do something with data. If they know that their chiller efficiency is supposed to be this and it's not, they can start asking the questions. Did I get the wrong chiller? Am I operating it improperly? They can start to get to the root of it. But if they don't have access to that data, they just say, the design team told me we had an efficient chiller, so it's efficient.
Yes.
The owner's projects requirement sheet, you said that's available. Where is that available? Is it on your website or?
The app. Little hamburger menu on the app, and we got a list of external links there, including that.
On the app?
On the Slido.
I think the QR code you passed out
The
gets
QR
to it.
Yeah.
code. The QR code.
we'll take you there. You say the hamburger menu, when you said that to me, I wasn't sure what you were talking
I
about.
thought
The
everybody
little
knew
things.
what a hamburger menu was. I read it and I thought I was a dumb one. So the hamburger menu is like bread, pastrami, whatever it is, burgers, lettuce, tomato, basically 3 lines.
If you have trouble finding it, just hand me a business card, I'll be more than happy to email it to you.
It's a very flimsy hamburger. It's like 1 line each.
It's not pancakes.
I think our original premise in wanting to set up this meeting today had to do with the fact that you could build energy efficient green buildings and not have cost owners more money. In fact, it would save money in the long run. I mean, that's where we started. That was the basic premise of the day that the 5 of us all started to talk.
I think it was more like a club sandwich.
You have to make.
Tell that to UX.
So maybe just a couple of stories. Each of you might have a story to tell about how this makes a difference.
Yeah, I have one. So you guys may be familiar with Sewickley Tavern project. It's a high-end restaurant. So the architect designed the roof, the ceiling in the restaurant so that it would knock down acoustics. And they spent a lot of money on the ceiling, so they put it in because you want to sit across the table from someone while you're dining and you can talk to them without being drowned out by noise. They also had some really interesting energy goals on the project, and the project is Reset Air certified, both core and shell and commercial interiors. So it's a really interesting project. So we set this project up and we brought them into the data layer because, you know, if you're gonna do a Reset Air project, you might as well set up a data layer. You've already paid for it, use it, and then you can have free value on other systems. So we set this up, and about a month or 2 into the project, the chef called the architect and said, it's about 100 degrees in my kitchen, it's too hot. And, you know, they kind of said, well, tell us tomorrow if it's still the same problem. We called back, and it took like 3 or 4 days. Finally, the architect called us up and said, can we look at the systems? We're like, yeah, no problem. So we got the MEP engineer, Donny wasn't on the job, but the MEP engineer, myself, and the architect, and we started looking at the data. What's the inside temperature? Yeah, he's not lying, it's hot. And then we looked at the outside temperature, and then we started looking at the equipment to see statuses and CFM. And what we noticed is there was supposed to be an interlock linkage between the makeup air unit and the hood in the kitchen where they exhaust all their air. And that was broken and it was missing commissioning, and it wasn't basically connected. And it resulted in that, and we looked at each other, and the MEP said, we did this in 5 minutes. He said, this would have taken a job site visit, us walking around trying to figure it out, possibly bring in some other people. In literally 5 minutes, we were able to bring trends in from alternative systems and be able to look at this and say, yeah, just we can see it right there. It makes total sense to us. And then we fixed it and it came back in. So the idea here is that once you start using data, like the BIM, when BIM became open, we started using it, clash reportings and schedules. We use it everywhere now, right? The same thing has happened in the BEM world, where we're starting to see there's value in using simulation over here. We're seeing in the data world now, all of a sudden, I have all these other uses that basically creep up and we can start doing it. We save ourselves a lot of time and money for it. So it's one example of how data really helped us.
Yeah, I think one thing that comes to mind is with the living building that we did at Georgia Tech. It was designed prior to COVID and turned over during COVID. And so to meet the net positive energy requirements, it was, you know, pretty easy. Yeah, we had a great solar array with an empty building. But what we were able to do, because we were, you know, taking that live data and overlaying it with the simulated data, is to say, what are those assumptions that go into the energy model, and how can we extrapolate the performance to say, what would it be doing if it were used in this manner? And by being able to clearly show that, the ILFI was able to say, okay, great, we can validate this building because now we can see how it's performing and how it will perform under different scenarios. And so now that the building is more populated, we're starting to see those graphs, you know, trend more to the expected levels, you know, still with a healthy safety factor. But we're you know, able to, you know, really validate that performance because the data speaks for itself.
I don't think I have any exciting stories to tell about that. You know, the stories would be just what we have been able to do from a cabling standpoint in a building that had challenges, you know, and how you address it with different types of cabling. We're working right now with a digital electricity product which is going into the arena and has gone into Heinz Field, mostly for the Wi-Fi access.
Okay. Any other stories anybody wants to tell?
I guess ask the question, does this open up any new ideas to all of you? I mean, that's kind of where we wanna be, you know? That you see yourselves being able to do things that didn't seem, I mean, I think if you were struggling with IT, now we're talking about the convergence of OT and IT, does it make it worse or does it make it simpler? It should make it simpler.
Yeah, if we can all converge during the design process and then converge all the technologies, and then understand them later.
The idea, somebody mentioned a single pane of glass, I mean, that's human-centric, that's simplicity, that your building managers, your owners can see how the building is performing. As you explained with the East Liberty Presbyterian Church,